Hello and welcome. My name is Brian Beals, and I'm the Director of Analytics and AI at LRS. LRS is the Tier 1 systems integrator headquartered in Springfield, Illinois. We specialize in analytics, AI, as well as security solutions. Today, we're going to be presenting and demonstrating a unique solution that allows our customers with multi-value databases, such as Rocket, Cache, and others, the ability to mask sensitive data fields in their multi-value databases to allow for governance, compliance with sensitive data. The highlights of what make our solution truly unique in the marketplace is our ability to not only mask the multi-value databases, but we can apply the same masking rules to relational and unstructured data as well, ensuring referential integrity across data sets in the enterprise. Joining me today are Steve Kavlik and Alan Martin. I'll be turning over the call to Steve now.
Thanks, Brian. Good afternoon, and thank you for joining us today to talk about this really important subject. I'm Steve Kavlik, Senior Solution Architect in the Analytics and AI Group at LRS. Discussions around data protection and privacy are as prevalent as ever. It's now vital to protect all of your data in all of your environments, including test and development. We often forget about test and development environments being potential targets for an attack, but they generally contain straight copies of production data. In fact, one Microsoft survey showed that almost 70% of DBAs answered that they use production data as is in their test and development databases. These test and dev environments are typically not as well protected or even monitored as production systems. In fact, Uber suffered a breach of test databases a few years ago, and the subsequent lack of policies and the cover-up, which is out of scope here, resulted in $148 million in fines. I think that we can all agree that the approach of copying production information into test and dev proliferates sensitive data, and it expands your boundaries of compliance, and it increases the likelihood of a data breach. Speaking of compliance, there are a myriad of regulations that have to be adhered to. HIPAA, CCPA, GDPR, just to name a few. Failure to comply could mean really steep fines, as our Uber example showed. These regulations require big changes in the way organizations collect and store data. These regulations vary from jurisdiction to jurisdiction and from country to country. So it's really important to standardize your approach to compliance, and data masking should be a big part of that strategy. Non-compliance with these regulations can lead to loss of intellectual property, losing position in your vertical or your market, and reputational loss in the eyes of customers and the public. Not to mention the average expense of fixing a data breach is now well over $4 million. To overcome the threats that come from both inside and outside your firewalls, data should be protected in layers of security. Data masking is a best practice and one of the layers that you should be utilizing in protecting your data. However, data protection must not be limiting. And by that, we mean that employees who need data to do their jobs, and we're talking about developers and DBAs, they need to have access to it and be able to use it in a meaningful way in order to improve or develop applications. Today, we're going to introduce a unique solution that can be used to mask your data in technically challenging multi-value databases such as Cache or Unidata. But the same solution can also be used in traditional relational databases. And that's really, really important because they may exist upstream or downstream from the multi-value databases. And this solution will not only mask all the different types of data, but maintain the referential integrity with those other sources during data replication or data movement that occurs during digital business processes. What you're going to see here today is not a prototype or a minimally viable product. This solution has been implemented before at an equipment leasing company with almost $500 million in revenue. In that scenario, an outside consulting firm identified at least a $4 million liability by not having test data protected. The biggest challenge was masking data in multi-value databases, and no less than 12 other partners tried and failed to achieve this. We've done it, and we're really excited to share this solution with you. Now I'm going to turn the mic over to Alan Martin, who's going to give a deeper dive into the solution and walk us through a demonstration of how this masking solution works.
Thanks, Steve. So when we talk about data across your enterprise, we're not just talking about your typical flavors of structured data. We're also talking about unstructured. And when I say unstructured, sometimes I mean semi-structured data. There's different interpretations. But when you hear me say during this conversation, structured data, I normally mean structured data like NoSQL databases, like your traditional flavors like DB2, Oracle, SQL Server, maybe NoSQL type data sources like MongoDB, Cassandra, MariaDB, and of course, key value paired databases like Unidata, Cache, Universe, and so on. When you hear me say unstructured, there's data out. 20% of data across an enterprise is typically structured or semi-structured, and then you have about 80% of data that is truly unstructured, and unstructured like PDF files, check images, MRI scanned images, or medical records, Microsoft Office documents, and these can be very challenging to mask. And as mentioned before, the ways, how do we protect this data, both structured and unstructured? There's different methodologies. And just to do some clarification here, when we talk about encryption and tokenization, that is obfuscating the data, but allowing it to bring the original value back. When we talk about redaction, really we're talking about permanently redacting the data to say something like X's and O's, or changing everybody's last name to Smith, or a social security number to all zeros, for example. And what our focus today is going to be on the masking obfuscation. And that, when I say masking, it's basically what I may call intelligent redaction, replacing a value with another value. So if we replace a name, we can replace it with another name. We replace it with a valid social security number, we replace the value with another valid social security number, and so on, like credit cards, MasterCard or American Express or Visa card. So today's focus is going to be on masking and not tokenization or encryption, or base redaction. And so where does the data reside? This solution can help us process this, both structured and unstructured data, across our enterprise on Linux, Unix, Windows, mainframe environments, iSeries, System I, and below on the slide, also on the unstructured content management repositories, for example, as well. And it's important, what we call completing the compliance circle. It's important to deal with this because a complete business object does not just sit nicely in a SQL Server table out there. A complete business object may have somebody's information in a Unidata database. That person may have related PDF monthly bank statements, for example, or insurance claims that have their name and sensitive data. So we really need a solution that can cover the entire spectrum of both structured and unstructured and mask this consistently, ensuring, again, we're completing the compliance circle and masking all the data. Because are you truly in compliance if you don't deal with the complete business object? And this brings us to UMask. So this UMask solution will allow you to mask over 160 different file types. As I mentioned, Microsoft Office documents like Word and Excel, Adobe PDFs, HL7 EDI, web logs, system logs, and so on. And in this image here, we can do check images, for example, as well. And these are all challenging. Images are stored as RGB pixel values. So this solution, again, will be able to do that and handle that and mask consistently. So that's enough for the slides. I'm going to go ahead and jump into the demo. In this demo that you're going to be seeing now, I have in our labs a Unidata database. I also have a SQL Server database as well, and the SQL Server database contains XML fields with sensitive information. We're also going to mask JSON and CSV and image in the unstructured area as well, and we're going to do consistent masking, which is very, very important. So we're going to get on with the demo. Okay, so hopefully you see my screen right now. Let's go ahead and take a look at the data sources that we'll be masking today. So on my desktop here, I have JSON files, CSV files, as well as images as well. But let's just take a quick look at the JSON file. You'll notice in the JSON file, I have a record called Christine, by Christine Huss, who was born on August 24th, 1963. Now, if I open up the CSV file, we should also see Christine Huss. Let me make that bigger. Hopefully you can see that. We have Christine Huss as employee record number 10, born August 24th, 1963. And then even if I look at this image here, we'll see Christine Huss has a bank check image as well. I also have a database, Microsoft SQL Server database, and let me just clean this up a little bit for a moment. You'll see that I have a sample table database, and I have a table called proposal XML. I'm going to select the top 1,000 rows, and in this table, SQL Server table, I have an XML field. And if I look at this XML field and I scroll down, you'll also see here I have Christine Huss as well in this XML field inside a SQL Server database. If we navigate over to the machine that contains the U2 server, I also have a database file called employee demo, or emp demo. If I take a look at that, let's take a quick look. Emp demo, and you'll see that in this Unidata database, we have also Christine Huss. So our challenge here is, how do we mask consistently values across a JSON file, a CSV file, an image, a XML field in a SQL Server database, and of course in our Unidata database as well. So we're going to use UMask to go ahead and do that. UMask allows you can be executed via a command line interface. It can also be executed through a lightweight GUI, and you can also call it using REST API services as well. In this demo, I'm just going to call it using the command line interface, as well as do a light GUI test here. So I created a batch file. By the way, UMask can also automatically build the command line for you, so you don't have to worry too much about syntax and figuring it out. And once you've got that command line built, you can then put that in your workflow process or in a task scheduler and execute that whenever you need to as part of that process. So I'm going to go ahead and double click on mask csv.batch file. I'm also going to go ahead and double click, let me move that, double click on the mask JSON file. You know, while we're at it, I'm just going to go ahead and mask the image file as well. Okay, great. What I did is I instructed UMask to not overwrite the original, which could have been easily done. I instructed UMask to make a copy of these so we can compare the before and after shot. So let's see, we have a mask employee JSON file. Let's take a look at this one first. You should see now that we have what was Christine Huss originally is now Danita Bernash, and we've changed the date, the birth date, to May 14th. What was it originally? It was August 24th, 1963. It's now May 14th, 1964, Danita Bernash. And if I open up the CSV file, the mask CSV file, we should also, let me make that a little bit bigger for you. Well, we also see that employee number 10 is now Danita Bernash, again in a different date format. Now is born 1964, May 14th. So we've masked the JSON file, we've masked the CSV file, and a quick look at the check here. We've masked from Christine Huss on the check image, we've now masked it to Danita Bernash as well. We've also nulled out the account number also. Again, I have a SQL Server instance, so we're going to go ahead and now mask this XML field in the SQL Server. So this time I'm just going to start up the lightweight GUI, UMask GUI. And the first step is we select rules. Basically, the rules are files that say what you want to find, like the field name or the value, like a regex value. And then how do you want to replace it? What do you want to replace it with? Either a string literal or another regex, or consistent format preserving encryption, which we're going to do here. Or again, we can replace a name for a name, a date with another date, a valid US social security number, or a valid passport number, or driver's license number with another valid, so that it maintains the look and feel of the data. So I'm going to replace Christine Huss's name. And so you specify the rules, you can build rules, and then you can specify build and execute. Here we can select a single file, or all files in a folder, including recursive, or we can just specify the database. I select a module. These modules are small programs that perform a specific task. Like we have a DB2 module, we have a MongoDB, ODBC, JDBC, and so on. We also have different modules to perform tasks against Microsoft Excel or Microsoft Word documents or PDF documents. So you specify the module that you want to use. I'm going to use the SQL Server module, and I created a rule called SQL Server. Now, if I click on Set and Run, and I say Generate Script Only, it will build. It'll build an XML file and execute that that program. If I uncheck this, it'll execute it immediately. So I'm going to click on Set and Run here, and hopefully what will happen now is it'll go ahead, it'll connect up to that SQL Server database, mask the data at hand, and if I go ahead and refresh this and rerun it, we should be able to scroll down now, and we should notice that the name, social security number, and other relevant information has been obfuscated or masked. You'll see first name Danita, last name Bernash. Okay, so now let's do the same for the Unidata database here. I'm going to select by module. This time it's umaster U2. I'm going to select the rule. I created a rule called Unidata. And now I'm going to go ahead, uncheck. So just go ahead and set and run. And now let's take a look at the Unidata table. You'll see that MDemo has Christine Huss. I'm going to go click on reload. Let's make this a bit bigger here so you can see it. Click on reload, and you'll see now Christine Huss is now Danita Bernash in the U2 database. So this is just like a little bit of an introduction on U2 and consistent masking across your enterprise. And I'm going to hand it back to Ryan. Ryan, all yours. Thank you very much.
All right. Thanks, Alan. Let's go into some Q&A session here.
Ryan?
Yes, you're good.
Okay, great. So I'm looking at some of the questions here. I see one question, what about conditional masking? So I guess the question is, what I'm showing you here is that we can also do conditional masking, meaning if you have business logic in your across your enterprise where maybe you have a field or a value, a field that is shared with, like, I don't know, like a tax number or a company corporate tax number and maybe an individual's SSN, and you only want to modify the SSN, we have the capability of writing conditional, we call them an override file. So you can call a scripting language like Lua or PowerShell if it's on a Windows machine, or if it's Windows PowerShell, Lua scripting, Java, and you can call external processes to do conditional masking. So you can look at the value of the field. If the value of the field contains a certain, let's say we only want to mask people in the state of Texas. So we can do it if then else type of conditional masking to say, if the state code is Texas, then mask it one way, else mask it another way. So we have that capability because a lot of times, even though we have out-of-the-box masking solutions, there's going to be a lot of times where you want to do conditional masking as well, based upon your company logic, whatever that may be. Let's have a look at some of these other questions. So I see a question here. What happens if there's an error during the update phase? So basically there's two methods of doing this, but what the solution does, it'll do a direct connection to the database, it's the SQL Server instance or the MongoDB or the Unidata instance, and it does an update in place. The first step, the way it works is it'll pull the data into an in-memory data table, in an in-memory data set, just the fields that you're interested in. And then once it builds that in-memory database, it'll then go through and process the table and update that in-memory table. And the final step is to connect back to the target and perform the update. And so if there is an issue during the update process, like a network connection error or something like that, then we do stand a chance of potentially corrupting the table. And so, what most people do is they'll create a staging table and mask the staging table. Depending upon the volume, because sometimes we're dealing with millions, hundreds of millions of rows, or even sometimes we have billions of rows. And that billions of rows, if we do have that, and as I mentioned, it loads it into in-memory. So the good thing about that is that the there's no unmasked data, production data that lands on disk. It's all handled in memory and then updated back. The bad thing is that it's limited to your memory size. So if you have a table that has billions of rows, how do you mask that? Well, we also have a conditional selection. When you're building this table or running processes in parallel, you have the ability to specify selection criteria or subsetting in a way, and so that subsetting will allow you to do chunks of the workload and load it into memory, kind of like in certain batch sizes. So if there's an issue or an error, we can either restart one or specify commit rates as well. So I was just seeing another question, and so yeah. So the question is back to let me read out the question here. Actually, it says, is there a risk of the encryption type being cracked and having the real data reconstructed? So when we talk about tokenization and encryption, as I mentioned in the slide before, when we talk about tokenization and encryption, it means that you can get the original data back. When we do straight redaction or the data obfuscation, the masking, it's the whole idea of that is the use case is to not be able to reverse engineer or get the original information back. If you change everybody's last name to XXXXX, the question is, can you get that data? Can you retrieve what the original person's last name was? And the answer is no, you can't. But is it good test data? Is it a good example of data? No, it's not, because you want to mask a name with a name of a social or valid US address or whatever it may be with another valid address. So I'm giving you a long answer, but the short answer is no. It cannot be reverse engineered. It's not designed for that. Now we have had requests. Where they said, well, we want to be able to reverse engineer it. We want to be able to get the original value back, kind of like a encryption type of methodology. In that case, we have written utilities and routines to store the original value or do a cipher technique which gets us the data back. But most of the use cases for this, as Steve said a little earlier, most of the use cases of this is when we do production, we move production to test or to QA or to dev or sandbox or training environment. That's kind of that's been the primary use case. It's also been, that way you back up production and you redirect the restore to test, and then you mask that data and then allow people to start developing and working on that. The other use case is when you need to share information outside of your organization or even between departments sometimes. And so through compliance, we have to ensure that the PII data has been, masked / redacted. And so that's, when you have a third party company that does analytics for you and you need to share information with them, you can't, you need to ensure that there's no PII sent to them so they can do their analysis. It depends upon what you're getting them to do. Also, when you open up trouble tickets, when you open up a trouble ticket with, say, IBM or Oracle or outside vendor, and they want you to give them your trace logs or your trace files or your system logs of relevant information, and by law you can't do that. And so this tool would be used to obfuscate the sensitive data that's not required, and then send that information outside of your database or outside of your environment. So it doesn't really, it's very different. It's very different than tokenization or encryption. It's a one-way masking. And the product's been around for many years. And the masking algorithms that used have been around for over 20 years. And it's proven that there's not been an instance that we are aware of that someone's ever been able to get the original value back. Again, it depends on what you're masking and what masking functions you're using on that. I see another question here. What methods could we use to mask Unidata data? What methods could we use to mask Unidata data and send it to Oracle or vice versa? So what I showed you the demo I showed you is a direct connection to let me show you is a direct connection to the Unidata or the database. But there's another methodology here, and the methodology is to leverage export and import utilities, or to leverage the database utilities or processes to be able to export the data out of the database. Most database utilities allow you to export data out to a unload or an export file. Then you can mask that export file. Let's say it's an XML or a JSON format maybe. And then instead of going back to the original, you can use that export file and import it into a different data source. So, I'm confident that Oracle has abilities to import, let's just say, make it easy and just say JSON or CSV. DB2, Oracle, SQL Server, have your bulk copy programs. They all have that capability to export and import. So to share data between your Unidata, cache database, you can leverage the database utilities to do the exports. And we have a process, the successful process that we leverage to export that data out of it instead of direct connection, mask that data, validate those export files first, and then once we've validated the data, then we can then import it back or import it to another target system, depending upon what type of export methodology we've used on that. I think, Ryan, I saw another question come up. I'm not sure if I missed that.
Alan, Steve here. It looks like there's another question that came up in the chat and has to do with whether or not the masking can work with only static data or whether you can actually mask active data. So the question is about what database locking and whether or not this can be used on a live or a quiet system only.
So that's a good question. So in short, yes, we can do dynamic data masking with this tool or with this process. So if you've got data in flight, you're sharing information, you can grab the bytes potentially, or the packets or the messages, and mask that data before going into a database or coming out. And that's a good question. That's happening quite often these days, where we have customers that require dynamic data masking. And just to let the team know here, that those of you who are listening, is that we have the capability to mask data. Let's just say, for those of us who are DBAs, mask data on views or mask particular data depending upon who's requesting or who's looking at the data. So as an example, let's just say a manager, Julie, has access to a data. When Julie accesses or runs a query, or maybe she has an Excel spreadsheet tied to a JDBC, ODBC driver to a SQL Server database, for example, or DB2. When they request information, we can dynamically mask that data on the fly using this process, or not. And so Julie, the manager, could see the data. Whereas Alan, if I do the same request and we set up permissions, user groups and roles, then when I do it, all or part of certain fields are obfuscated or masked. So that gives us a kind of a dynamic data masking process that allows us to mask data either in flight or depending upon who's asking for the data. And we've had requests. I mean, it's not just the typical stuff of PII data. We've also got requests for IP addresses, for example, for system logs and things like that. And we've worked for the government entities, both state and federal. We've worked, a lot of large Fortune 500, Fortune 100 companies on this. And so, that is a good question. And in short, yes, we can do dynamic data masking.
Alan, I've got one more.
Just
have to do just a question around the scalability of the solution. And of course, we're always driven by time, and we always promise service level agreements back to the business. Mm-hmm. So if this has to be completed by a certain time, whether it's overnight or by 6 o'clock in the morning, what are some of the factors that can affect the scalability of the solution? So obviously it's the number of pure records that are going to be masked, but mm-hmm. Are there certain data types, whether it's integers or characters, versus masking something in an image that will make it scale or go faster?
Yeah, so you're correct. The first is volume. How many records are we wanting to mask, whether it's inside the database or it's a lob or a clob or a blob? inside the database or outside of the database on a file share. Here, we've had customers that do monthly statements in PDF documents, and those PDF documents, they have millions of customers. So we'll need to mask on a scheduled basis millions of PDFs. So yes, it's definitely the volume and the data type. The database, we could have a table with 3 fields in it, the first name, a last name, and maybe something else, a middle name. We could have a table that has 400 fields or columns on that. And of course, the wider the table and the volume, the more performance degradation there is. And then we start dealing with blobs and clobs and JSON and XML fields. So the XML field I showed you in this demo, I have to check. I think it's either 32K. It might be 32K in size or 3.2K. I'm sorry, I don't have it here, but that field contains thousands of bytes. Not just that one field. So yes, it's all about performance. And if you have a service level agreement, the way we've designed this as well is you can chunk up the jobs as well and run them in parallel, depending upon your methodology. And so if we're doing a direct connection, we're doing it all in memory, you're going to run out. If you have it depends if you have 1 billion rows or 1 million rows, we're going to, however large the file sizes may be in the database, this is just related to databases, then we're at the mercy of how much memory you have on your machine. But you can also execute this, like I said, you can set up the batch processes and run them at the same time if you like, or if you unload the database to an unload file or an export file and sitting in a file share, you can then chunk up the responsibility and run things in parallel. But that is a challenge. And again, it depends on your SLA agreement, whether you have it overnight, to your point, Steve, or whether we have to do it in a certain amount of hours or over a weekend or something like that, and the frequency of access and masking as well. Hopefully, you're not going to be doing this, all the time. If it's the use case is the development, the QA test and refreshes, then I don't know how often you do your group might be doing refreshes, whether it's daily or quarterly or monthly or whatever it may be. Again, you'd have to design performance tuning into this, and that can be a factor when the size, the volume, and the data types and things like that can be a factor in that. Let's see, I don't see any more questions here, I think. Hopefully this is making sense and I'm not talking too fast.
Yeah, I'm not seeing any either.
Okay.
Or Ryan.
Yep, Ryan, how are we doing on time, by the way, in team?
We're doing pretty good. I think we're good to wrap up without any more questions, unless you have anything you want to tag with.
No, I think I'm okay. Okay. Just that, again, what's been mentioned is this is a mature product. It's not an MVP, minimal viable product. It's been around, been tested, tried and true. So, and I guess, Ryan, if anybody has questions, follow up to this, can they reach out to us at all, or is there a methodology for that or not?
Yeah, you can reach out to analytics@lrs.com. You can also respond to the login information email. That's rhowarder@lrs.com. That comes directly to me, and I can get you to the right person. I'll also send out later this week a link to the recording of this if you want to share it or review anything in it. And we'll have some more information in there. But otherwise, gentlemen, thank you for presenting today. And everyone, thank you for attending.
Great. Thanks, Ryan. Thanks, Steve.
Thanks a lot, Ryan.
Thanks, Brian. Thanks, team.
All
Take
right.
care. Bye-bye.